and we follow
Yes.
your instruction.
Yes, yes, okay. Let's see. It looks like you have connected everything, which is looking good. Did you install the software on a laptop? Yeah. Yes. Then you have your microphone cable, which you already plugged in. Microphone cable is connected to the microphone itself. And the microphone is positioned by a magnetic stand. There's a microphone holder here, you can clamp it down. You can reset this to any position you want to. And if you turn this knob loose, you can have a flexible movement of the microphone. Yeah? So basically you position it to the microphone position that you want. I have the same ceramic sample like the one that you have. In dimensions, and the frequencies of this sample will be different because it's a different sample from the one that you have, but it will be more or less the same vibration behavior. Yeah. The ruler is used to position the wires, and we'll get back to that later on when we go to the software. This is to set up your node distance. So each sample, depending on its length, has a node distance where the vibration of the flexural mode is 0. And that's where we want to position these wires. Yeah? But I will show you later on, so don't worry if it's not completely clear. And then you have also the automatic excitation device. This is positioned between the two parallel wires and will shoot against the sample from the bottom, and the microphone will capture the vibration signal. Okay. Yeah. So that's basically the setup that you need to have. Yeah? Okay. Let's see if I can switch back. Okay. Okay, from the top. It looks like this. Yes. Yes. Okay. I have to take some colors. That's maybe a little bit more easy. Go. Okay. When I tap this sample, and I do an excitation from the bottom. So I shoot something against the sample, then it will vibrate. And this is what we call the flexural mode. And I have to draw it a little bit better, but the flexural mode looks like this. So you can imagine looking at the side of the sample, it will vibrate like this. Yeah? You can see that there are 2 points here. Okay. Where the vibration is, the amplitude is 0. And that's what we call the nodal point or the nodal line. Very important term that you need to understand, because that's what we need to set up the sample later on in real life. Yeah. So when you enter the length of the sample, then we know from literature that these nodal points can be calculated. It's a fixed distance, it's always the same. So if you enter the length of a sample in the software, it will give you 2 numbers, the node and the node distance. Yeah? So the node distance is the distance between the 2 nodal points, and the node is this one. So you have the node and the node distance. Yeah? This one is important. The 2 flexible wires on the support, yeah, they need to be set up in this number. Yeah. Take a different color.
You see, the two flexible wires on your wire support are these wires. And that's where you position the sample. You can only find out these positions if you know the length of the sample. Yeah. In this case of the reference path, it's 80 millimeters. So if you enter the 80 millimeters in the software, it will calculate to, I think it's a little bit over 44 millimeters. This one. More or less. So this is flexural mode. This is linked to Young's modulus. If I enter the sample dimensions and mass in the software, I do a measurement and I measure the flexural vibration mode, then I can calculate Young's modulus. There is a second vibration mode that is important to us, and that's the torsional mode. And the torsional mode, you can imagine, if you have a rectangular bar-shaped sample and you tap it from the side, it will do this vibration. Not this one, which is the flexural, but the torsional vibration. Yeah? You can get a torsional vibration if you tap from this side, for instance, in a corner, and then you have nodal lines in this way. So across. Yeah? And that's where the second wire comes in. The cross-shaped wire is to set up the sample in this way. Yeah? If you want to characterize a new material, something that you don't know, you always do it in 3 stages. First you do the flexural mode, because it's the easiest to identify. Once you have identified the flexural frequency, then you can proceed to a cross-shaped setup and measure the torsional frequency. And when you have identified both frequencies, then you can do a combined measurement. So you can do flexural and torsional in one and the same measurement. And then you get Young's modulus, shear modulus, and Poisson's ratio for isotropic and homogeneous materials. Yeah? So this is a little bit background on what the wires do on the sample support. Yeah? Can you see my software now?
Yes.
Okay, perfect. Good. And so it's a different one, not the one that you have. This information, 55. So this
你
is
知道上面这个，如果是的话是130504。
对啊，130504。
Here's what happens if I enter sample length. Then these two numbers will change, because these are the numbers that we calculated earlier at the node and the node distance. If I enter 80, you can see that the node is almost 80 millimeters and the node distance is 44 millimeters. So again, that is the distance from the side of the sample to the first zero amplitude vibration of the sample, and the distance between point. Yeah? Then we have the sample length, which is 34.99, and the thickness is 8.95. Okay. This is basically everything I need to enter for the sample, the reference sample that you have. Yeah. Then you get this 44.16. I'm going to stop sharing my screen and switch to camera again. Oh, that's not good. That's not looking good. So we talked about the 44 millimeters. Yeah. So you can see I have one wire here at the 10 centimeter mark. Yeah. The second one we need to set it to 44 millimeters.
We cannot see the rule.
You can push the top
We cannot see the number.
push it,
到16，
and then slide this back and forth. Yeah? We now go to 44 millimeters. You do
44
that on and you do that also on the top.
44，
14.4
Like that, we can do a measurement. We need to set up the excitation device and the microphone. Yeah? For flexural measurements, these ones, you want to tap the sample in the center. So if you look from the side, you want to tap it right in the middle here. If you look at it from the top, again in the middle. So position your excitation device in such a way that it's perfectly in the center of your sample. So between the two parallel wires. So this one needs to be like this.
Yes.
Yeah? Okay. I will see if I can switch again to my mobile camera. 44 millimeters is
它
perfect
有
enough.
不会转，
It does not need to be completely perfect.
没有，
So indeed set the wires to 44, and then your wires are completely set up, and then you can position the sample on the wires. And try to position it nicely in the center, so this distance and this distance is more or less equal.
Yeah, yes.
在中心点。
嗯，下面
Yeah.
OK，
Okay, perfect. Then you need to position your excitation device in the center of the sample. See, you can move it around. You can position it everywhere.
没有，上面那块拿起来看得到。
不是啊，
Very good. In the center of the
它
sample.
从下面照。
它距离它有多近？
然后在它中间，
在它中间就好了。
你也找照片。
Yeah.
很目测对啊，
Ah, looking good. Looking good. Very well. Okay, the last thing we need to do before we can start a measurement is to position the microphone. Because it matters where you place the microphone to detect vibration modes. If I go to the screen here, if I tap the sample here, I will not get a flexual frequency because it's in the antinodes of that vibration mode. But if I tap it here, yeah, I tap in the antinode and I get the most amplitude from the vibration. So in the flexural mode, I want to position my excitation device here, and I want to position my microphone on top of the sample. Yeah, in line with the excitation device. So in this
手还
case,
是直的，
I will position my microphone like this.
因为这个是直的，
直接贴在上面。
它没有贴纸啊，
没有贴着，它有接，
Yeah.
它有缝的。
So
有缝啊。
OK，
use a slight angle, so not perfectly straight, but use a small angle.
不是垂直，
小写
有一点。
它有几度？
How about the angle, the degree, angle degree for the microphone to the sample?
Sorry, what is the question?
My question is the camera to sample. What is
麦克风，
microphone? The microphone to samples. What is the angle degree?
It has to be a slight angle. There's no certain degree that you need to have. It needs to be on a slight angle. So let's say 10 to 30 degrees is fine.
10到30度。
这样长，
差不多。
小写的就好
它。的倾斜。
OK。
Yeah, and why do we do this? When the vibration of the sample goes upwards, it goes to the microphone here,
那高度
where it will be captured, and then it will be directed outwards. So the vibration, I have nothing to point here. Then
高度的麦克风离
the
身。
vibration will go up
麦克风
against the microphone,
Yeah.
then go away from the sample.
Yeah,
If
Mickey.
you put,
Sorry,
Yeah.
how about the distance, the gap between the microphone and the samples?
yeah, let's say 5 to 10
这个是这样。
millimeters
5 to 10.
above
5
the
到
sample.
10 mm 哦。
有啦，
对啊，差不多啊。
Okay, okay,
1公分，1公分。
So not like this.
okay.
It will work, but it's not that good. You can position it 5 to 10 millimeters above the sample.
应该
5 to 10.
有啦，差不多。
OK
1公
OK
分以内，1公分以内。
perfect。
Yeah. Okay. Now you have your setup complete. So the hardware is set up completely. You're ready to do a measurement. Yeah. But first you need to do some settings to do a measurement. So in the measurement screen on the bottom right hand side, you can go to settings. Yes. Perfect. And then you get a new window. From left to right, the data acquisition stop is set to noise level. I'm going to switch my camera because that's a little bit more convenient. So data acquisition, if you click noise level, you get a drop down menu and you have two options. And you can click noise level. Yeah. So you have noise level and maximum measuring time. Noise level, what does it do? I'm going to sketch it again. If you do a measurement, and this is your signal and time domain. If you do a measurement, basically what happens, the software will listen to the environmental noise, the noise that's already in the room, and it has a certain trigger level. So once it exceeds the trigger level, it will do a measurement. Yeah? So this is the noise in the background. Normal office background noise. Everything that you hear is this. Yeah? When you do a measurement, you tap the sample, then and you exceed a certain trigger level, then the software will recognize, hey, you guys did a measurement, I need to start recording the signal. Yeah? So it listens before you do the measurement, and it actually saves the measurements once the trigger level is exceeded. Yeah? Now, when is it going to stop recording? Because you cannot record endlessly, and you need to stop somewhere. And then you have two options. So the noise level, what it does is it looks to this level, so the noise level. And when the signal is going below the noise level, it will automatically stop recording. So that's noise level. Second thing that you can do is, okay, my signal here only lasts for, let's say, 2 seconds, but I want to record 3 seconds anyway. Yeah? And you can switch to maximum measuring time and say, okay, I want to record between 0 and 3 seconds. And that's somewhere here. Yeah? So, noise level will only measure the signal length as it is, and it will automatically stop. Yeah? Maximum measure time, then you tell the software, okay, even if the signal is 0.1 seconds, I want you to record that amount of time. Yeah? When the excitation is going up in this way, it needs to be
这个讲这个，
something like this.
刚才讲高度不够，
没有，他说最高的高度是这样子的，
Yeah, you can adjust, you can put it higher.
这个可以转吗？
他不能碰到样品，
不能放样品，
像有他讲像 哦，它下面可以转，
下面可以转，
可以转，
嗯，
它转它变高。
So this tip, it cannot touch the sample.
Cannot.
If it's,
很大的，呀，这样
if
没有
you
碰
don't
到，
do a measurement, it cannot touch the sample. It needs to be something like this. Let's say 10 millimeters between
10
the
Equal
tip
time.
and the sample. I think that is better. Yeah.
再触发一次。
等一下哦，
Put it back in the center of the sample.
要放在中间哦，样品的中间。
嗯，好，
这条线是不能放空，好，
OK。
Okay.
碰到，
Ah, there we go.
它是需要碰到吗？
就是还没有，
So the torsional mode is where we need to reset wires cross shades out and cross shades. Wait, yeah. So go back to your setup. Remove the sample first. and take it away so it cannot fall down. And take the sample and just put it away for a moment.
然后自己编号编下一个，你看我再按一次，然后它档案都自己出。你按接手。
Okay. So we remove the sample, just put the microphone out of the way, and the excitation device. And now you can move this wire down. So it looks like this.
哦，是
另外一条人的那条往下，
他现在要测透视，
他现在测另外一种模式。
测有没有旋转？
是翻转，
同学是扭力吗？
嗯，
扭转，
它移到什么地方？
移到中心吗？
中心下面吗？还是
正中心吗？
应该是吧？
应该是样品的
是
侧
正中间。
对短边的正中间。
对啊，正中间。
Yeah, did you manage to do that?
看我没有，让看看。
拍给他看。
Now you can place the sample on this pulse. Like so.
不知道太远。
太远。
太远。
我这样拍到吗？然后我这样看不到自
You
己
see?
都按了。
没有很。
有这边。
Now, correct?
Yes. Perfect. Okay. And now you put the excitation device somewhere
要打侧边。
打
here.
1/4的地方，就是这边其中一块。
So it's on the side of the sample. So it's not here. It's not here, but here on the side of the sample,
边边。
and not in this corner, but a little bit to the center of the sample.
应该可以。
可以啊，就这样，应该照你们距离。
应该可以。这样子。
对，就在边上
拍。给他看。
有啊。
看到吗？
Like that. Yeah? Okay.
啊，很接
他就
近。
希望我们这个再
That
推出去一
looks
点。
that looks fine, yeah. Vibration modes. So flexural as well as torsion. Because if we can do that, then we can identify the Young's modulus, shear modulus, and also calculate the Poisson's ratio. And you have a combined measurement. And that's what we are going to try to do now. So in order to do that, to go back here, switch to my camera. Yep. Okay, so now I will remove the microphone. We'll have a little bit of room. Remove the sample. We no longer need the cross wire. We just need the two parallel wires. So this one and this one. And we reset the sample the same way that we did as in the flexural mode. Yeah? The difference is the automatic excitation device now needs to be in the corner of the sample as much as possible.
尽量在边边。
You see?
See.
Yeah.
So as much in the corner as possible. And now we do the same for our microphone. We position it aligned with the excitation device. So your setup looks like this. Yeah, perfect. Perfect, very good. Doing well, guys. Okay, so if you now again click measure,
测试。
hey, now we have both frequencies. And you have 8,155, and you also have 10,461 hertz. And these are the two frequencies that we identified earlier on. Yeah. So now you can go back to settings E and G. And in mode, you switch not to torsion, but to flexural and torsion. And it already recognizes the flexural frequency, 8,000 hertz, and it already recognizes the torsion frequency, which is 10,000 hertz. So if you now click OK, Now it calculates the Young's modulus, shear modulus, and Poisson's ratio of your sample. So good job.
Major.
You identified first material with impulse excitation. Very good. Okay, remember to save because you're not in automatic saving mode now. Huh? So it's not storing the information at this time. So you need to click save and then save. Yeah.
True.
Okay, if you put it on continuous now, you can do as much measurements as you want, and then it will save all the information in the RDF file. I will show you.
Okay.
So around this, to characterize around this, you need two frequencies. Again, the flexural frequency and the torsion frequency, but the ASTM standard, they call it differently. They have different names. What you need to know is that you have two nodal lines. Cross and a circle. And you can imagine if I tap the sample here, it will also vibrate in a torsion way. Huh? If I tap the sample here in the center, it will, they call it the breathing mode. So the sample will vibrate also in a sort of flexural mode. Yeah? So it's basically the inside of the sample that goes up and down. Something like this. You can see that you have four intersections. Yeah? These points. This is where the vibration amplitude of both the flexural and the torsion modes are zero. Yeah? So if you want to measure a disk on this sample support with this instrument that you have, again, we recommend to use the cross-shaped wires. Yeah? And then keep in mind that this circle is an antinode. Is a node, sorry. The vibration amplitude here is zero. So if you want to excite a round disk, do not do it here, but do it here on the outside, or here on the inside. But not on this circle. Yeah? Again, disks are a little bit more tricky to characterize. You need some more experience before you start to do disks. Do you have a disk-shaped sample lying around somewhere that you can use?
No, we do not have the round.
No,
we do
okay.
not have. We return it to customers.
Yeah.
Thank you.
Yeah,
Bye bye.
thank you.
Bye bye.
Bye.